Just like I promised, here's question 6 on page 263. Again, I've prepped all of it just to save time. It says a square of side x, there she is, in there, is removed or cut out from a triangle of card as shown. So it's a yellow triangle, cut out the x squared, get rid of it. The remaining area of card is 5 centimeters squared. So all this area around that hole comes to 5 centimeters squared. Part A. Form an equation for the area of the shaded part, in other words the remaining card. So it's basically the area of a triangle, take away the area of the square, and then that comes to 5, which is what I've done here in the first line. Area of a triangle, half base times height, so half times 3x times x plus 1. Take away the area of the triangle, minus x squared, area of the square, minus x squared, and that equals 5. So half of 3x is 1.5x. Multiplying out this bracket here, 1.5x times x, 1.5x squared, and 1.5x times 1, 1.5x, minus x squared equals 5. 1.5x, let's highlight this little bit, so 1.5x take away a whole x, 1.5x squared take away a whole x squared is 0.5x squared. So I've got 0.5x squared plus the 1.5x there equals 5, and I'm bringing the 5 over next door and subtracting to make it look like a quadratic with 0 at the end. That's what I've got. Final answer, 0.5x squared plus 1.5x minus 5 equals 0. And that's the equation that represents the area of this triangle minus the square inside. Part B, simplify this equation in the form of ax squared. Okay, ax squared plus bx plus c equals nothing. In other words, get it in the form of a quadratic where everything's on the left hand side. Now, in a way I've answered the question, but in order to avoid this ugly 0.5x squared, if we multiply by 2 throughout, we're going to get this. Multiplying by 2, well, half x squared doubled becomes x squared. Half of 1.5x is 3x, and double 1.5x is 3x, and double minus 5 is minus 10. And that is a very, very neat looking quadratic equation. And that's part B done. Alright, so the area of the triangle is equivalent to x squared plus 3x minus 10 equals 0 when written in the form of the classic quadratic equation mode, so to speak. It then says construct a table of values for the quadratic, and I'll be using this one here. I won't be using that one, I'll be using this one because it's nice whole numbers. Construct a table of values for the quadratic, and I've got to go from 0 to 3 in intervals of 0.5. So 0, 0.5, 1, 1.5, etc. And you flick over the page, there they all are. Absolutely brilliant. So again, I could have used this one, I didn't use it, I've used this one instead. And I've substituted x values, you can see, 0 squared plus 3 times 0 take away 10, well that equals minus 10. So I'm constructing, as is usual, a table of values to get the x and y coordinates in order to plot the graph. Here we go, here's the last one, 3 squared plus 3 lots of 3 take away 10. Well, that's going to be 9 plus 9, 18, take away 10 is 8, hence the 0.38 as an example. Alright, and so I've done that. Draw the graph of the quadratic, essentially plot these coordinates and see what you get. That's what you get. It says use your graph to find the x value which satisfies the equation in part B. Well, that's the equation in part B. That's what we've plotted, this here. And in order for this to be equal to 0, I've got to see where this graph here intersects the line y equals 0 or the graph y equals 0. A line is a graph, makes no difference. So I've already done that and labelled it just there. So where does x squared plus 3x minus 10 equal 0? Right there. And the solution is x equals 2. Alright, so where the blue line crosses my red x-axis, better known as the line y equals 0, we have the value of x equals 2. Alright, now then it asks us what are the dimensions of the triangle and the square. Well, if you recall the triangle, we have a base of 3x and a height of x plus 1. So let's just do the triangle here quickly. It's working blue now, I think. Stand out. So the triangle got a base equals 3x, which means 3 lots of 2 which means 6 centimeters. Alright, very simple. And the height, I recall, is x plus 1, which means essentially 2 plus 1, therefore it's got a height of 3 centimeters. And the square is dead easy, because it just goes x by x, doesn't it? And that's going to be a 2 centimeter base by a 2 centimeter height, and that's that. It's beautiful. That's all there is to it. However, producing this and getting the solution x equals 2 took a long time. Let's just recap quickly. First, subtract the area of the square from the area of the triangle, end up with an ugly little equation there with half x squared in it. Double up to get it in the form of ax squared plus bx plus c equals 0, and that's this one here, and it's very, very attractive. Create a table of values for this equation. There they are. Plot the coordinates we've generated. There I have. Draw in the line and see where it intersects with the line y equals 0. There it is. The solution is x equals 2, and therefore the x equals 2 is common to the x value in the triangle and the x value in the square, because it's the same x in the storyline. And they're the dimensions. The base is 3x, 3 2s are 6. The height is x plus 1, 2 plus 1 is 3, and the square, of course, is a 2 by 2 centimetre square. And that's it in terms of recap. I won't do question 7, it's far too over the top. I'll begin to prepare some of the assess questions now, maybe 3 videos in the assess, and that should look after all of us then. Okay, so thank you. Time to get a cup of tea, I think.